ಇಲ್ಲ ಅವ್ರು ಇನ್ನೂ ಬಂದಿಲ್ಲ, ಅವ್ರು ಬಂದಿಲ್ಲ ನಾನು ಹೇಳ್ತೀನಿ. ಹೌದಾ? ಇಲ್ಲಾಂದ್ರೆ ನಿಮ್ಗೊಂದು ಇಮೇಜ್ ಹಾಕಿದಿರಲ್ಲ, ಅದು ಹಾಕ್ಬಿಡಿ. ಹಾಂ, ಈಗ ಇಮೇಜ್ ಹಾಕ್ಕೊಳ್ಳಿ. ಹಾಂ, ಲೈನಲ್ಲಿ ನೋಡಿ ಕಟ್ಟಾಯ್ತಲ್ವಾ?
from here I will be able to give data to about 15 people online onto their mobile. And I am bringing a digital image processing so that we will teach the kids how to do image processing on this. That is also part. I will explain that when we talk. So that way we have made a good
ಕಟ್ ಮಾಡಿ ಹಾಂ ಮಾಡಿ ಸರ್.
Thank you. Akash Ganga, Surya Chandra Tara. The song, originally composed by Kanu Ghosh, is set to a melodious slow tune. This Gujarati song talks about the cosmic Milky Way, sun, stars, and evening twilight. Whom does it belong to? The land, rivers are ubiquitous and belong to everyone. Hopes and downs are part of life. The clouds and rainbows are beautiful with its multiple colors. May I call upon Srimati B.V. Rajalakshmi, Srimati Lakshmi C.R. and Srimati Purnima J. to render the invocation song. Koni sagar dhara, koni bhumi, koni nadi, koni sagar dhara, bhed keval shabd hamara ne tamara, akash ganga, surya chandra tara, sandhya usha, koi na nathi. Meghadanu andar na hoye kadi jango, Meghadanu andar na hoye kadi jango, sundarta kaaj banya vivid rango, akash ganga, surya chandra tara, sandhya usha, koi na nathi. Akash ganga, surya chandra tara, sandhya usha, koi na nathi. Thank you for the melodious rendition. Atiti Devo Bhava, meaning the guest is equivalent to God. I request the President of Mahila Seva Samaja Managing Committee, Srimati Parimala S. Rao, to welcome the gathering.
Good evening.
ಇದೆಯಾ
Dear Dr. Kiran Kumar, our chief guest, Dr. Divakar, Dr. Sita, Dr. Guru Prasad, Sri Girish, and Mr. Narsimha, the alumni of the 1972, committee members, teachers, and students. It gives me a great pleasure to welcome you all to this inauguration of Astro Club in our school. I thank Dr. Kiran Kumar for having made time to come in spite of his tight schedule. With his vast experience, I am sure he will be able to give our club a very useful idea. Thank you, Dr. Divakar, for being a mentor of this club. Thanks also to the alumni of 1972 who have graciously come forward to help the students in this new venture. This will open up new vista for them to learn about cosmos and view the stars, sun and moon differently with curiosity. Thank you all for being here this evening with us. Thank you.
Thank you, ma'am, for your warm and cordial welcome. Mahila Seva Samaja was established in the year 1913 by Srimati Parvati Amma Chandrasekhar Iyer. Since then, the institution has carved a niche in the field of education by the selfless and dedicated efforts of educators, facilitators, and well-wishers. The school continues to uphold and follow its vision, continuous pursuit of excellence through wholesome education. I request Srimati Revati K. Suresh, Secretary, Mahila Seva Samaja, Managing Committee, to share the highlights of Mahila Seva Samaja with the audience. Thank you, ma'am.
Good evening, ladies and gentlemen. It gives me great pleasure to meet all the dignitaries, committee members, staffs, students, guests, and especially the 1972 batch of students at this inaugural function of Astro Club. This is the first meeting with so many people after the pandemic. The inauguration of the Astro Club is making me an astrophile. That's the glamour of the club. I feel very happy to be with our dear little friends here and travel into space listening to our leaders in this field present here today. I once again humbly welcome everyone present here and thank our chief guest Sri Kiran Kumar for making our dreams of a journey to space come true. Another important feature I would like to proudly share with all of you is that this is the Space Week celebration, 4th to 10th October. We are venturing into this great field through our own Astro Club inauguration on the 9th October 2021. World Space Week is an international celebration of science and technology and their contribution to the betterment of the human condition. One of the goals of the World Space Week is to excite young people about science, technology, engineering, and math, or in short referred to as STEM. World Space Week 2021 celebrates women in space. Kalpana Chawla and Sunita Williams are great examples having an Indian origin. I want to quote our own celebrity under STEM. Srimati Rajeshwari Chatterjee is an alumni and granddaughter of our founding member Kamalamma Dasappa. She was recognized by the Government of India for being the first woman graduate from Mysore University by giving scholarship for her master's degree in USA. She was the first woman engineer from Karnataka. Mahila Seva Samaja has been doing human surveys to women in the field of education from the past 108 years since its inception on 1st October 1913. We are moving forward with a lot of enthusiasm to keep up the well-founded traditions and values imparted by the institution to women and children. We have had great eminent personalities visiting the school, leaving their imprint of great thinking and ideals, helping us in our balanced growth of the institution. We have had eminent leaders like Mahatma Gandhi ji, Srimati Sarojini Naidu, Srimati Indira Gandhi, Dr. Kiran Bedi, to name a few. The royal family of Mysore, the Odayars, were our patrons. Sir M. Vishveshwaraya was not only a patron but also guided the working of the school. We have had Sri P.C. Ray regarded as the father of chemical service in chemical science in India, visiting the school in 1926. Kalam visited the school on May 2nd, 2014 and inaugurated the science wing of our senior secondary school. We will work with leaders from all walks of life to take us forward in our quest for excellence in education. Eminent space personality is now here to lead us in the path of understanding stars in reality and in life. The 1972 batch of our students have played a major role in the starting of this Astro Club today. They are responsible for the many equipment like the telescopes, binoculars, etc. and training of the Astro member students as well as planning all its activity. Mr. Divakar has led the way in the entire process. I wish all the very best to the functioning of the Astro Club, giving a strong foundation and valuable inputs to the members of the club. Thank you.
Thank you, ma'am, for giving us an insight of the Space Week celebration from the 4th to the 10th of October, the contributions of Samaja towards women empowerment, and its association with eminent personalities from all walks of life. To quote Dr. APJ Abdul Kalam, a dream is not that which you see while sleeping. It is something that does not let you sleep. Dreams transform into thoughts, and thoughts result in action. unquote. May I now request Dr. P.G. Divakar, the expert facilitator for the Astro Club and also an alumnus of the 1972 batch of our school, to share the dreams and aspirations of the Astro Club with the August gathering.
Respected Kiran Kumarji, President, Vice President, Secretary of the Mahila Seva Samaja, the committee members, my beloved 1972 batch members who are all sitting here in the third row onwards, the kids, the faculties, teachers, and rest of all the people who are joining in from the virtual mechanism also. It's indeed a great honor for me to be here on the stage with Kiran Kumarji, who has been our mentor all the way through, to do something small for this particular school. In my much younger days, 1 year I studied here, 7th standard. The rest of my classmates have studied much more than what I did here. But we have a very special love for this school all the time. That has only made us to get into a WhatsApp group, and then we have been continuously together for a long time. And this technology also enabled us one fine day to see that we can do something for the school, especially after the pandemic. We thought there should be some kind of a contribution, so we all thought after a lot of discussion that it should be something like an Astro club, which we thought would be a contribution in the long run. In the sense, this it's not just setting up a Astro club, but making it function, give it all the necessary technology that we can, with whatever knowledge we have and with whatever resource persons. In fact, 3 of our resource persons are already sitting in front of me. They are all my ISRO colleagues, Dr. Guru Prasad, Dr. Sita, and also Dr. Girish. All the 3 of them are here. They will be playing a major role with me, and I will be getting a lot more resource people from ISRO, and of course I will take a lot of help from Kiran Kumarji also, because he is the ultimate as far as knowledge on astronomy is concerned. What we plan to do in this particular venture here is that we take the kids to a newer level of something which is away from the normal academic courses. Normal academic courses does teach them a lot of physics, chemistry, maths and things like that. But here they will be doing a little bit of astronomy, in fact more of astronomy, and a lot of mathematics also with that astronomy, and they will try to learn physics and many other subjects. It's always a great experience if you look at the skies, if you try to look at the planets, if you look at even the moon, that everybody knows. Even when we were kids like them, we used to always imagine what is really there on the moon, what is really there in the skies, and what is the galaxy all about, and things like that. So we thought that if we put up an Astro Club today, it will be possible for us to show them those things practically, make them do things on their own, and also ensure that they get the practical knowledge of what astronomy is all about. Towards this, what we have already done is from a little bit contribution what we all put together, we could buy a 10-inch telescope with a Dobsonian mount. 10-inch telescope was just now inaugurated by Kiran Kumarji, and we have here 2 6-inch telescopes on the left and right side. So we have 3 telescopes already in the initial stage. Not only this, we also have 2 very interesting binoculars which will give you a larger coverage of the galaxies. Means you will be able to see even some moving objects, like there is also already in this particular month meteor shower. So if you want to really look at it, provided the monsoon clouds allows you to see, it should be possible for us to use the binoculars to see them also. Not only this, we would also be attaching a DSLR camera, wherein you will be able to take digital pictures from these observations what you make, and these digital pictures we can take them into digital image processing, where we will teach the kids how to do image processing, enhance these images, make some meaning out of these images. So there's going to be a whole lot of interesting activities that we will be bringing in as part of this venture. We were thinking the best time to do all these things, particularly observation, would be, let us say, starting from November onwards up to May. So October now we are inaugurating this. Next month onwards we should be really starting off observations itself. It's not that we will do observation every day. It will be planned in such a way that kids don't spend too much amount of time only on this. They have to balance with the academics also. So we thought we will do it on a Saturday so that Sunday they can relax and Monday they're back in school. So at least in a month we will have 2 observation sessions and then possibly another day within a week or 2 days in a month we will have some expert talks on astronomy and related subjects. So we will keep the kids occupied in the entire month with at least 4 sessions in a month, every month. But of course, down the line, when monsoon comes in June onwards, when we move on up to October this month, it will be difficult for us to do observation. But what we are thinking of doing that time is, whatever observations have been done, whatever digital images have been captured during the observation time, we will start making use of that data and we will start making the kids process those data and make some meaning out of it. So we will keep the students occupied with this unique expedition to space just from the top of your building itself. So you don't have to really become astronauts to understand the skies. You will start understanding the skies from the telescopes itself. We plan to have possibly some more good telescopes down the line so that better observations can be done. One more thing which I missed out is that we are thinking of getting some, in fact we have already got a Wi-Fi attachment to this which allows the images that are being seen from the telescope to be beamed through a router for about 15 mobiles. So straight away you can get the data onto your mobiles, and we are going to provide some interesting tools and apps on the mobile. Like, let us say, for example, SkyMap is one of the top class astronomy related application which can be put onto your mobile, and just like the way you use Google on the ground, you can start using the SkyMap to understand what is happening in the skies, which particular planet is coming up, when it is going to set. So when is the planet rise, when is the planet set, you will be able to observe. So depending on that, you will be able to make the plans. In addition to all these things, we also would like to take the kids to the planetariums, to let us say Kavalur Observatory and many other astro clubs outside here, so that they will get an idea of what others are doing in the astronomy related activities. Unfortunately, Bangalore is a polluted place, particularly from the light point of view. Even though we have excellent observation space on the top, you may not be all the time able to see everything what you want to see. So we plan to take you to some unique places from where you will be able to observe the skies much better. In fact, just you can sleep down on the terrace of a building, open your eyes, you will be able to see galaxies yourself. So that kind of a plan also we have. So we have a host of plans for the kids, both the sides. I see a lot of kids here. I'm sure there are a lot of kids online also. So you will have a wonderful time with us, and we will ensure that you all get a unique experience of astronomy with the kind of gadgets what the 1972 batch of Mahila, Seva, Samaja has been able to provide to you. So thanks to our batchmates for having done this, and we plan to take things forward in a much bigger way. Thank you very much.
Thank you, sir, for sharing the plan of action. After hearing you out, I'm sure all of you will agree with me. We are all excited and we are looking forward for the Astro Club activities which are scheduled from November onwards. May I now request Srimati Sheila Murthy, Academic Director, Mahila Seva Samaja, to introduce the chief guest to the audience.
Thank you, Shri. To be inspired is great, but to be an inspiration is an honor. Today, we have one such personality amongst us. Good evening, ladies and gentlemen. It's my privilege to introduce our chief guest, Shri A.S. Kiran Kumar ji. Mr. Kiran Kumar is a highly accomplished space scientist and an engineer with a distinguished career spanning over 4 decades in ISRO in the satellite payload and applications domain. He's a Vikram Sarabhai professor at ISRO, Bangalore, and member of the Space Commission. During 2015 to 18, when he was the chairman of ISRO, he also served as Secretary, Department of Space. He completed his BSc with honors in physics in 1971 from Bangalore University, MSc Physics in 1973, Bangalore University, with a specialization in electronics, MTech in Physical Engineering 1975 from the Indian Institute of Science, Bangalore. He was instrumental in evolving the successful strategy for steering the Mars orbiter spacecraft towards planet Mars, as well as its Mars orbit insertion. He also made significant contributions for evolving the observation strategy encompassing land, ocean, atmospheric, and planetary studies. He is responsible for the implementations of the applications-oriented Indian space program, which has facilitated important spheres. In this pursuit, he steered the development of satellites and related technologies for Earth observation, communication, navigation, meteorology, and space science, as well as the development of indigenous launch vehicles and related technologies for providing assured access to space. His contribution award for the year 2013, Gujarat Ratna Life for Innovation Award conferred by Gujarat Innovation Society, Laurels for Team Achievement Award 2018 for Cartosat of International Academy of Astronautics, Bhaskara Award conferred by Indian Society of Remote Sensing 2007. He has also been conferred with many prestigious international awards. In 2018, he won the International One Karman Wings Award instituted by the Aerospace Historical Society together with Graduate Aerospace Laboratories at California Institute of Technology. In 2018, the icing on the cake is the Chevalier d'Ordre National de Légion d'Honneur. I'm sorry if I've mispronounced. It's a French honor, the highest civilian honor by the government of France in 2019. So he has a lot of awards to his credit. We are indeed very happy to have you here with us. Thank you so much.
Thank you, Sheila ma'am. To quote Plato, astronomy compels the soul to look upwards and leads us from this world to another, unquote. I request our Honorable Chief Guest, Shri A.S. Kiran Kumar Sir, to kindly inaugurate the Astro Club of Mahila Seva Samaja. Also, I request the dignitaries on the dais to kindly join the Chief Guest. May I request the audience to give a big round of applause. Indeed, it's a moment of pride and joy for Mahila Seva Samaja. sir, for doing the honors. Thank you all. Dr. APJ Abdul Kalam once remarked, "Look at the sky. We are not alone. The whole universe is friendly to us and conspires only to give the best to those who dream and work." I now request our Honorable Chief Guest, Shri A.S. Kiran Kumar, to kindly address the gathering.
Good evening to all of you. Shri Divakar, 1972 batch students of this illustrious institution run by Mahila, Seva, Samaja, President, Vice President, and all the members of this institution, the committee members, and my dear students and their parents. It's indeed a great privilege to be part of this program here today, where students who have passed out of the school thought it fit to contribute to the growth of the next generation by providing unique opportunities. Today, we see that many of us, when we have gone through our schools and our younger days, the kind of opportunities that were available were very limited. But then, if India has to grow, India has to make a difference to the globe, apart from what it has already done now, and if it has to truly become what it once was, the only way is the next generation, the younger generation, should be given enough stimulus and opportunities to learn things and know about technology. Today we are all quite familiar that if mankind on this planet is living better standard of life compared to people centuries earlier or even millennia earlier, it's only because what science and technology has brought out and how people have built newer and newer tools, and with those tools the society is able to carry on its activity with less physical labor and with more intelligent use of tools and knowledge. And in this context, I should really compliment the 72 batch students for thinking it fit to do their part to a school where they studied. And once again, my compliments to Divakar and all his friends here. See, I was also saying that India has a great heritage. It has a heritage where human beings, you can imagine even thousands of years back or 10,000 years back also, every individual looks at sky because it's very, when the sun sets, what we see, moon, planets, and many times different, even those days without light pollution of today, even galaxies were easily visible. But then gradually man realized that there is a lot of repetition of patterns in what is happening in the sky. So slowly they started recording their observations, and based on that, and particularly in India, the entire understanding of year, the formation of years, the seasons, and how to link the seasons with stars and zodiacs, and then how to even tell ahead of time when what kind of rains will come. All this happened with human beings just looking at sky and then looking at repetitive patterns over a period of time.
and painfully recording their observations in their own memory to start with, and later as tools change, the way of recording changed from maybe on stones or on drawings or finally even on written material. But then today we know that human beings have brought in so many new capabilities, so many new tools, that many of the things that is happening in this world has changed drastically. We are also quite familiar that way back in 1957, the first object was put into space. Just to remind you, actually every one of us, even as of this instant, we are sitting on a planet which is moving, going round the sun, and the solar system itself is going round the galaxy, and many of these galaxies are moving away from each other, and we are moving relative to sun at almost 20 to 30 kilometers per second, and we are also rotating. So, but none of that we feel. When we go on a scooter or a car at 100 kilometers or 150 kilometers, we feel, oh, so much is happening. But all of us are traveling at this point of time at tremendous speeds in this universe. But then that moment is insignificant in this entire universe because the universe is so vast. And today what you are getting into, the opportunity to look at space and then seeing things, what I was mentioning is way back in 57, when Russians put their first object into space, Sputnik, it was actually an intense competition between two superpowers, Americans and Russians, who were trying to demonstrate who is more mightier in military prowess. But then at that time in India, we had a great visionary scientist. Probably many of you would have heard of this, Dr. Vikram Sarabhai, whose centenary year we celebrated recently. It was his vision that this new technology of space, how can we make use of this for the benefit of our country? Because we had got our independence in 1947 and 57 was just 10 years after that. And it was his vision that brought in the starting work of space technology. He made use of his friendship with American, Russian, French and German scientists and brought sounding rockets in the form of kits. See, like for example, even this telescope, it's in the form of a kit which can be assembled, all the parts. In the same way, sounding rockets were brought from abroad. And the first launch took place in our Tumba Equatorial Rocket Launching Site. And the program of space technology started in India. Before we start talking about our advances or our development in space technology in the astronomy area, I would just like to remind you of a couple of very important things which India has done in the area of space and why India is considered as one of the unique users of this space technology development. See, like I said, the first sounding rockets were launched in the Tumba Equatorial Rocket Launching Site. At that time, to launch that, the actual assembly was done in a dilapidated church in the beach. And for conducting that experiment, Dr. Sarabhai had to convince the fishermen in that beach with the help of the priest of that church, telling the fishermen, today if you vacate this place and give us the opportunity to conduct these experiments, one day in future, the country will benefit. Just as though to prove this point, from 1999 onwards, India was able to provide the fishermen in our 7,500 kilometer long coastline. You can imagine there are millions of fishermen. From an entity in Hyderabad, by looking at the color of the ocean through the satellites going around the earth is looking at the ocean, and by looking at the color of the ocean and thermal fronts and identifying the food chain of the fish, we were able to tell where in the ocean if the fisherman goes, he can get an assured catch of fish. This alone saves to the country between 15 to 20,000 crores a year, because fishermen don't have to search and don't have to spend extra fuel like petrol and diesel. And to this capability, we added when we brought in our navigation satellite, Navig satellites. Today, a small gadget, mobile, in the hands of the fishermen in the ocean. The gadget need not have any connectivity to the terrestrial tower, but because of the Navig satellites communication to that, the gadget fitted on the boat, and boat that, like what Divakar was talking about, Wi-Fi, through Wi-Fi connectivity or Bluetooth connectivity between the gadget in the boat and the fisherman's mobile, fisherman is able to get in his mother tongue information about the fishing location, and also like a video compass, the mobile shows him where to go for fishing, and if there are going to be any weather vagaries in the coming days, if it is going to be cyclonic after 3-4 days, or sea state roughness is going to be unbearable, the alert comes to him in his mother tongue. So you can see here, a person who does not know reading or writing is able to make use of the most advanced technology of rockets, satellite being sent into space, and instruments from the satellites providing information to the livelihood of the fishermen. In the same way, India is also able to provide for the cyclone information, cyclone landfall. Super cyclones are no longer able to take tens of thousands of lives of our coastal zone people, which used to be the case earlier decades. And then today, India has more than 50 plus satellites which can give the capability of looking beyond the boundaries of the country, and then also tell about the crops, crop yield, and a host of other activities. I am sure in the coming days the students will be able to learn many of these through the websites of Bhuvan platform in NRSA, etc. One of the things India also did is to build the capacity in the country and to enthuse the student community, space science, which is, while the satellites in orbit can look at Earth and give very useful information for the development, whether it's in the communication, broadcasting, meteorology, or Earth observation, etc. It's also possible to see from space towards sky. See, you can imagine just now, for example, when Divakar was telling, during the monsoon months, that is between the June to September, India is filled with clouds. So obviously when you want to look up in the sky, clouds prevent you from looking at the sky. Similarly, there are days when the atmosphere can hinder your observation of stars and planets in the sky. And again, we have atmosphere between Earth and space, and this atmosphere also absorbs the signal coming from the stars or the distant objects, and our ability to look at space gets affected. So if you can go out of the Earth's atmosphere, then you can make observation of celestial objects with much greater resolution, and much finer things can be done. And in this context, I want to talk about one satellite called Astro, where today India has made a mark in the global arena. Today this satellite, which was built in our country with instruments developed in the academic institutions of our country, whether it Indian Institute of Astrophysics, Bangalore, Tata Institute of Fundamental Research, Bombay, Inter-University Center for Astronomy and Astrophysics, Pune, Raman Research Institute, Indian Institute of Science, Physical Research Laboratory, like that. They built the payloads for that, and the satellite was built in India, and we launched it. It carries a telescope operating in the ultraviolet region, far ultraviolet region, and it has the world's highest angular resolution telescope operating today. And not only that, it has got a sensitivity which is very high, And because of this, for the first time in the world, Indian scientists are able to look at a specific zone in the deep space and look at signals coming from deep space billions of light years away. Probably, if you know that light travels at 3 lakh kilometers per second. At this speed, if you travel for 1 year, it's called a light year. And billions of light years have elapsed, that much distance the signal has traveled, and this satellite is able to pick up that signal and show very new information to the world community. So what this shows is that though we started our activity much later, we have economic resource constraints, many other constraints, still the intellectual capability and the ability to overcome the problems that you have, you can be first in the world and you can create actually ripples in what is happening in scientific world. In the same manner, probably you will all be very familiar, Chandrayaan-1, which was done in 2008, that time also, while man has landed on the moon and a large number of probes have gone to moon, the credit for discovering the presence of water molecules and then OH molecules on moon, that credit is given to Chandrayaan-1. Again, you can see, though we started late, the credit goes here. In the same manner, Mars mission. This is again, see, like many satellites what we built, initially we were taking it to something like 800 to 1000 kilometer altitude to go to moon, to go to geostationary orbit, that is for the satellites which look at the clouds and based on that cyclone predictions happen. There you need to go up to 36,000 kilometers beyond Earth. Moon is almost like 4 lakh kilometers. And then Mars is, when it is closest, 200 million kilometers and farthest 400 million kilometers. So when the satellite was launched on the 5th of November 2013, the task set out for this satellite was, it had to travel in space for 10 months, a distance of almost 600 million kilometers, and then reach a point very close to Mars on a particular day at a particular time. 24th of September, morning 7:30 a.m. 2014. At that instant, you imagine in deep space a cube of 50 kilometers. After traveling so much period, if this satellite was not inside that cube, we would not have been able to reorient it and make that satellite get captured by the Mars gravity and the satellite going around the Mars. And in fact, the entire world appreciated this task because India was able to do it in its very first attempt. Nobody had succeeded in such a Mars mission for such a long time. Now, why I'm telling all this is, on the occasion of this, is that the young student community in the country, today research community, even the AstroSat, for example, is able to provide virgin information to our research community. In the past, what used to happen is, whatever data that is collected by satellites of whether it is American program, Russian program, or European satellite, from that data had to be used, and invariably, first use is kept to the scientists of that country, and only after they have looked at it and tried to extract whatever results can come from that, that data will be available to the other scientific community. Now here we have for the first time our own data, and that data also from the world's best telescope realized in the country. So there is a tremendous opportunity for the next generation to make a difference, and the opportunities that you are getting today by participating in events like this, where you can look at what is happening in space and whet your own curiosity and also try and understand what is happening in the universe. And it is here that this experience can make a huge difference to your lives. The other important aspect we need to look at today is, unlike in the past when the space activities were being done only by government agencies, the world is changing at a very rapid pace. Today, we all know that, like what humanity did, land, conquering land, then ocean, conquering ocean through building ships and moving into different parts of the globe, and then airspace when it became available, commercial aircrafts, and then today you can go from one part of the globe to another part of the globe in less than a day, maybe 12 hours, 13 hours. Now, in the same way, space, which is considered as the fourth frontier, that is the ultimate frontier for humanity, because beyond planet Earth, if you have to go beyond planet Earth, then the space is the fourth frontier. Today, commercial entities, people like Elon Musk or Jeff Bezos, or a large number of private enterprises, they have entered into the space arena. Why are they doing it? Because they see opportunity, space tourism, space travel, space adventure, and then space exploitation. That means you can go to other planetary bodies or other bodies in celestial arena, whether it's an asteroid or Mars. Probably you also would have heard that there are companies which were selling one-way tickets to Mars, and then the people were buying such tickets also. Anyway, that apart, today space is an arena where private enterprise has entered, and they are pumping in large amount of money, and very soon you will see the kind of competition that is happening in the airspace. And in this, if India has to make an impact, how is it possible? This is where probably what you would also have been hearing, Government of India has made a huge thought process change. While ISRO provided the country over the last 6 decades basic capability of space technology, Indian entities, whether it's academia or the private entities, if they have to make a contribution and earn revenue from the space economy is supposed to be $400 billion, and if India has to make use of it, it can happen only in the private enterprise. And even in India today, there are a number of startups who are working on building rockets, building satellites, and this arena is hotting up, and students of today have an opportunity to build and then participate in this area. And when more and more students, when they are in a very young age, start thinking about it, they will become the new venturers, adventurers, and by that time they actually become people, they become their breadwinning or earning times or mid-youth, they have a tremendous opportunity. In fact, just the other day I also saw that a lot of books are being written by people. The moon, colonizing the moon. There was a book written in Kannada by one of the IPS officers of Karnataka cadre, who has written a book on this, and where she has visualized that already there is a habitation on moon and human beings are traveling to moon on a regular basis, going through a point called Lagrange point, where you don't need much energy to keep the object in space. So like this, and they're already fantasizing and what is happening. Like what was pointed out, it's only when you dream of making, that is where the events like whether it is a movie of gravity or those people who write fictions of science fictions, what was science fiction yesterday becomes a reality today or tomorrow. So that's how things move on. So anyway, I can keep going on and on. So I would like to stop here and then take this opportunity once again to thank Mahila Seva Samaja for giving me an opportunity to come here, talk to you something about what India is doing in the space arena, and also tell you that all the students and the next generation have a tremendous opportunity to bring India back to its true position in the global arena. Why am I saying this? Probably many of the students may not be really aware that in the early part of the previous millennia, if you look at the India was among the top 2 countries in the world, and it had adventurers who were traveling on ships to all parts of the globe, and economically it was very strong. And after a long period of actually you can say rule from whether it is the Mughals or earlier to that other, and then colonial rule, we had an education system which was tremendously impacted, and now we have an opportunity to remind ourselves that we had a great past, and that great past looked at not only science and technology outside the human being, but it also taught to look inward and then realize that what you are probably seeing outside can also be realized looking inwards. And it is this, and if, for example, the Astro Club also can start looking at what were the Indian astronomers of the past, what kind of things they did, and how people like Canada, etc., made even gravity studies, etc. It would not only remind them of what existed earlier, but also it will give them an opportunity to make new insights and new findings in the coming years. I would urge this club also to look at this aspect and also look at the opportunity that is available. Indian Space Science Data Center at ISTRAC facility, and maybe one of the trips you can take them to our the Deep Space Station, where India has built 100 feet diameter the telescope operating in the microwave region, and that it's like while this telescope operates in the visible region, you have microwave region, radio frequency region. India has built many telescopes, so that also could be shown. So in the end, again, thank you very much for the patient hearing, and thank you for giving me an opportunity to talk to you.
Thank you, sir, for sharing the various success stories of our space scientists and their commendable contributions with all our students. I'm sure your speech is truly a stimulus to all our young students who have gathered here and also who are watching us through the live streaming. We have our students from class 9 to 12 amidst us. Now these students will have the opportunity to interact with our chief guest, Kiran Kumar sir. Over to you, students.
Good evening, sir. Myself, I am Bharat Bajvi. I am 9th standard. I am studying in 9th standard. Sir, nowadays there is a lot of talk about intergalactic traveling, sir. Is ISRO also researching on the same?
Okay. See, one of the things I would like to tell you about is, see, India is growing economically, but at this point of time, we still have resource crunch. If I were to tell you, India, what money it has spent on its space program, right from its inception till now, all the money added together, even after accounting for what is called value of money, means money which was 1 rupee 50 years back, maybe today is maybe 100 or 10,000, something like that. So value of money changes with time. But if today we were to add up all the money we have spent, that is still a fraction of money on the space program. So when the resources are limited, while though we may have an intention of doing many things, we may not be able to do that. So what you are telling, the intergalactic studies, etc., for that, doing any specific research on that, today resource constraint is there, but there is no resource constraint for thought processes. So visualizing and thinking about that and then doing calculations, etc., on that work can happen. That is where academia is expected to do, and probably if you have deep interest continuing when you grow up, when you get into universities, etc., you could be doing such a thing. But ISRO itself is still very much, you can say, tied down in activity to meet the immediate requirements of the country. See, today we have provided, like I said, about 50 plus satellites, but for a country like ours, we need more than 100 operating at any given point of time. But for that, we have resource constraint. So depending on how much money the government provides, things happen. So today, intergalactic travel, etc., is still in the paperworks.
Good evening, sir. My name is Shuktija from class 12. Sir, it's common knowledge that solar panels are used for any satellites to recharge itself. But what happens when a satellite or a rover is placed on a planet such that the sunlight is blocked?
Okay, see, when the sunlight is blocked, and if sunlight is available at least some part of the time, then the panel can get charged, generate electricity, and put it in storage devices like a battery. See, like today you have got UPS, when power goes, you have a battery system which is getting charged. So most of the time what is done in all these satellites is the panel looks at the sun for some period. During that period, whatever electricity is generated, that is used for not only operating the instrument, but also storing in the battery. And when there is no sunlight, battery provides the energy for the various instruments. So the same thing happens even on the planets, where, like suppose in Earth itself, if you take in the night, you cannot generate sun using the panels using sunlight. So it's stored. In the same way it happens in the other planets. But then if you go far and far away from sun, then that light also will not be available for you to generate. So those times, other methods you have to find out. One of the methods that are currently done is using nuclear energy, and in the future people are talking about how to extract energy from space itself, from the vacuum of space itself. These are the thought processes that are today going on, how to generate energy from deep space. But those are the challenges of youngsters like you.
Good evening, sir. I am Amu Kumar from 9th standard. People say that planets were discovered in the year 1781, but in ancient temples of India, we can find Navagrahas. How did India discover the planets, sir?
Yeah, this is precisely one of the points which I was trying to tell earlier. See, definitely what planets existed and what planets were there, they could be observed by human beings physically, and then by meticulous observations and then keeping track of them, they were able to even predict when a particular celestial object will come in what zodiac, etc., etc. So a lot of such knowledge existed, and then when somebody says, for example, whether a telescope was invented only in the Galileo, or even like what you are saying, planets were discovered in 1781. It's all lot of misinformation which has happened.
Thank you, sir. Good evening. I am Navni Ranjan from class 12. So please throw some light on mission Aditya.
Yeah, okay. See, today, sun is the source of all life on planet and the solar system itself. And then we all know that sun goes through it 11-year cycles, and then sunspots when they come. There are a lot of impact on Earth because of whether it is coronal mass ejection or whatever particles come out of the sun. And then you also would have heard, for example, when total solar eclipse occurs, scientists try to go to the place where they can actually witness total solar eclipse, and will be visible for a period of maybe 6 to 7 minutes or 8 minutes. Of that duration you can see, and within that short period they were trying to conduct a lot of experiments to understand. See, sun, when we are seeing the photosphere whose light we are actually bombarded with, will not allow us to see just in the vicinity of the sun, beyond the sun's photosphere, what is happening. So for that, when total solar eclipse occurs, that light gets blocked and you can see a portion of what is happening just beyond the sun's disk. Now, if you go to space and have a telescope, and in that telescope, if you block the light coming from sun, you can look at what is happening in the vicinity of the sun, the coronal mass ejection, magnetic field interactions, many things can be studied. So what Aditya is planning to do is, it is going into a point in space where the energy requirement for the satellite to be maintained in that location is very small. It's called a Lagrange point. And just to understand the basic concept, if you see, suppose you have two objects which are having a lot of gravitational force. If you bring in an object in between them, you can visualize a point where the two forces can balance. So it becomes very less energy required for that to remain there. So same way, these Lagrange points. So Aditya satellite is going to be placed there. It will carry a coronagraph. Coronagraph is nothing but looking at sun like when it is total solar eclipse, and then make studies of the region beyond the radius of up to 1.5 radius, up to 3.5 radii of sun. It can see what is happening. And similarly, there are other instruments also on that satellite, and that is what it is supposed to do. And for this, today, instruments are getting built in the country in various institutions, and ISRO is working on launching this in the coming year. So Aditya is basically to look at sun, providing 24/7 opportunity to look at sun, and then make use of coronagraphs to see in the vicinity of sun what is happening.
Thank you, sir.
Good evening, sir. I'm Renalini from class 10, and I would like to ask you that I read somewhere that if we look through telescopes like Chandra, we can actually see galaxies as they were 10 billion years ago. How does that work?
Okay. See, now, for example, when you look at star or anything on the sky, see the light that you are seeing, what limits your ability to see? The amount of light that gets into your eye, amount of signal you can get. That is the first thing. So as the object goes farther and farther away from you, the signal starts becoming fainter and fainter. That's why here you are looking at 6 inch. 6 inch means almost 150 millimeter diameter it is collecting the light. Whereas our eye collects in a very small few centimeters. Only it is that much aperture is there. So if you start collecting light from a larger and larger aperture, you can collect more signal. So you can see fainter and fainter objects. Now if you talk of an object which is 1 billion light years away, the signal that is coming from that, no matter in which electromagnetic radiation it is coming, it is a faint signal. So you have to build instruments which are very strong in terms of ability to pick up that signal. So the noise of that instrument should be very small, and then it should collect sufficient number of photons for making observation. So the Chandra telescope, if you talk about, it has got such a capability. in a particular wavelength region, and that's how it can see. Like I said, even Astrosat has seen in ultraviolet many billion light years away in a region called the dark region of space. And just to understand the whatever Big Bang that is supposed to have happened, initially there was no light coming out from anything because matter was nothing could come through the matter that existed. Then as it started cooling, at some point the emission started, and that's what scientists are trying to look at. So what you are asking is, what Chandra did is such a thing. In a particular wavelength region, it is able to collect very small signals and make observation. Thank you.
Good evening, sir.
Yeah, maybe you can call then next week. Okay, go ahead.
Good evening, sir. I'm Banu from class 9. My question is that the space between galaxies and stars expand through time. Why is it and what makes it expand?
Okay. Now, one of the things that's talked about is, see, as the whole universe itself, when it formed, it was an infinitesimally small point, and then it exploded. Now, when it explodes, then obviously things start moving away from each other. That was one of the starting points. But then there are also thinking today that is it simply going on expanding like that, or are there changes in that? Those are the problems which both theoretical studies as well as experimental studies are trying to understand. And Hubble, for example, was one of the first persons who started telling that this expansion of the universe is happening at what rate and what is the measure of that, like parsec, etc. So they were able to do. So these are the problems of the understanding the universe that exists, whether it is going to keep on expanding like this or will there be a change.
Thank you, sir. Good evening, sir. I am Kiran from 11th standard.
My namesake.
So, in ISRO, how do you prioritize between two projects when they arise at the same time?
Okay. The prioritization of the project can depend on two things. One is money available for you. Second thing is that project itself, for completing the project, what kind of resources you need within the system, whether we already have many of the components, etc. See, for example, when the Mars mission was done, probably many subsystems what we had, we were able to use from the projects that had already been completed and some projects which were going on. So that's how some things could be diverted from one project to another project. So given the priority will be resources available to you, and then the time required for completing that, and then its utility for the country as a whole. So all these three things will be looked at and then priorities set.
Thank you, sir.
Good evening, sir. I am Harshita from class 10. There is a certain gap between two stars. What is present in the space between the two stars?
Okay. Now, typically, intergalactic space or whatever this is there is supposed to be hard vacuum. Initially it was started as no material, but then as time keeps moving and as we start learning more and more, it's also said that for some infinitesimally small period of time, something can emerge from that space and again, like positron and electron type of thing, or positive matter and negative antimatter, they can come out and then recombine. All this kind of thing is happening. So for future, people are thinking of how can we actually extract energy from such things. See, today also probably you would have learnt about dark energy. Today, the entire universe, if we were to understand, we do not see how we can explain what is existing with the current knowledge. So this area is very ripe for research and things are going on for a lot of youngsters to come out and then find solutions. And in future, if intergalactic travel and other travels have to happen, whatever technology that is available today is inadequate. Like I was telling, today we have capacity maybe 10 to 15 kilometers per second speed. But you need hundreds of kilometers, thousands of kilometers per second for travel. Then only you can go to places like Mars or other places, maybe in a few days or few weeks. Thank you.
Thank you, sir.
Good evening, sir. I am Shri Vibha from class 12. What kind of career opportunities do we have in this field?
Yeah, like I was trying to tell you, today space is becoming the fourth frontier. Like in the earlier era, airspace, if you take, aircraft started and travel has happened. Same way in space, today people are talking about space tourism, space adventure, space exploitation, and then even colonizing things, etc. Not only that, using space technology for improving the living standards on Earth by looking at how climate is changing and solving problems, etc. And economy-wise, space economy, they say today is about $400 billion a year. And very soon it is going to become $1 trillion a year. That means economy-wise also there is a huge opportunity. And today if you see, many youngsters and many new startups are starting their activities in the arena of space building. For example, today Elon Musk is talking of making a 42,000 satellite constellation operate around Earth for providing internet connectivity to anybody on any point on the Earth. So like that, lot of new things are happening and things are becoming more and more, you can say, opportunities are going to be available. But then depending on how you shape up, what interests you have and what kind of thing you want to pursue, you can actually become a part of such economy.
Thank you, sir, for answering the students' queries with such immense patience. And thank you, dear students, for your active and enthusiastic participation. Thankfulness is the beginning of gratitude. Gratitude is the completion of thankfulness. Thankfulness consists merely of words. Gratitude is shown in acts. As we come towards the end of today's program, I request Srimati N. Sri Lakshmi, Headmistress, Mahila Seva Samaja State Primary Section, to propose the vote of thanks.
The universe is full of magical things, patiently waiting for our wits to grow sharper. Good evening, one and all present here. I deem it a great honor and privilege to propose vote of thanks on this memorable occasion. Let me first of all thank the Almighty for making today's occasion a resounding success. First and foremost, on behalf of the management, I extend my sincere thanks to our chief guest, Shri A.S. Kiran Kumar sir, who despite his busy schedule has found time to grace this occasion. Thank you, sir. I also express my heartfelt thanks to Dr. Divakar for his valuable contribution. I also thank our special invitees from ISRO, Dr. Sita, Dr. Guru Prasad, Shri Girish, Shri Narasimha, for their gracious presence on this occasion. I extend my generous thanks to all the special invitees and guests to be kind enough to take part in this event. I also thank Shri Ramohan Sarangan for being a part of today's program. I take this opportunity to thank MSS batch of 1972 for attending this great event of our school and making it very successful and memorable. My sincere gratitude and thanks to all the members of the managing committee for their constant support, encouragement and guidance. Thank you. I thank our academic director, Mrs. Sheila Murthy, and manager Shri Nagesh for their support and cooperation in making the necessary arrangements for this event. I also thank Mrs. Rajalakshmi, Headmistress of State Board, Mrs. Shri S. Iyengar, Principal of CBSE, for their assistance in organizing this event. I would like to thank Mr. Manohar for the coverage of the event, which has gone live. Nearly 760 students from both state and CBSE streams are viewing this live stream at the moment. They have been fortunate enough to be backed by a team of very proactive and dedicated staff of our institution for their involvement and their willingness to take on the completion of the task beyond their comfort zones. I would also like to thank the people who work behind the screen to make this event happen. Our technical team, stage setting, lighting arrangement, and housekeeping staff. Last but not the least, I thank all the students for their active participation. Thank you all.
Thank you, ma'am, for your kind words of gratitude. I request all our dear students to please kindly come over the dais and accept a book from our honorable chief guest. I think we can start with Bharat. Bharat, please come over. Students on this side, please come this way. Please introduce yourselves as you come over here. please introduce yourself? Thank you, sir. Thank you so much. I request Mani to kindly dim the lights so that all of us can look at this beautiful arrangement. The credit goes to our team of teachers who've been really working very hard to put this up. So, yes, we would love to hear a big round of applause for their efforts. Thank you, teachers, for doing such a creative task. Thank you. Before I sign off, dear students, do you remember the popular poem from your kindergarten days? Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. The time has now come where you could all make best use of this opportunity through the Astro Club activities to gain great learning experiences. I thank you all for making this program a grand success. As I sign off, I wish one and all present here Happy Navratri. Stay safe, stay healthy. I remain Mrs. Shri S. Iyengar, Principal, Mahila Seva Samaja, CBSE. Thank you. I request our honorable committee members, Sumati ma'am, Sandhya ma'am and Meera Murthy ma'am and Jalja ma'am to kindly come over the stage for a picture. Please ma'am. After their picture is clicked, I request all the alumni of the 1972 batch to kindly join us for a photograph.
Music.
Can I have the experts, the faculty members also from ISRO to kindly join us for a group photograph?